Hello students, my name is Ashwini Kumar. I am from David Jalandhar. Today I am going to give you a lecture on numerical solutions of differential equations. So next single step method is Taylor series method. Now you know in your previous classes earlier in plus 2 as well as in BTech first year semester 1 class where you have learned calculus that what is Taylor series. Taylor series is the approximation of the values near to the values what we know. So in this method here y is given to you at x naught, right? Now x1 is what? X1 is the neighboring value of x naught at a step size of h. So we can calculate the value of y at this neighboring point x naught plus h with the help of Taylor series method. So in your previous classes, as you have expanded the series, what will be the series? Y at x naught plus h will be equal to y naught plus h y dash plus h square by 2 factorial y double dash plus h cube by 3 factorial y triple dash and so on. So this is your Taylor series, standard Taylor series as you have learnt in your previous classes. So we will use this methodology to calculate the values for our solutions, and this method is called Taylor series method. So for example, say suppose this is your initial value problem in which this is your slope x plus y, this is your initial condition. At x0 we have given the value of y to be 1. Now we have calculated the value of x equal to 1.2 with the step size h 0.1. Now what is the meaning of step size 0.1? We have given the value of x equal to 1. That means we will take the two steps. First of all we will calculate the value for 1.1 and then we will calculate the value of 1.2 with the help of 1.1. So let us find first of all first step at which x naught is 1 and y naught is 0. Now see, this is what? Y dash. So y dash is x plus y. What we will do, we will take the derivatives with respect to x with the help of this y dash. So you can easily see y dash is x plus y. That means y double dash is 1 plus y dash. Take the third derivative, that will be y double dash. Take the fourth derivative, that is y triple dash, and so on. Number of derivatives increases the accuracy of this method. As much as derivative you will take, you will find more accurate values, right? So after getting all these derivatives, what we will do? We will find the values of these all. See, this is your x naught and this is your y naught. Now, what is y naught dash? Y naught dash is the value of slope at the point x naught y naught. So this is your value, right? You just substitute the value of x naught and y naught here, you will get the value of y naught dash. Similarly, when you substitute the values of y naught dash and x naught as well as y naught, you will get the value of y naught double dash. So substitute the values, you will get the y naught double dash. So by substituting all these values one by one, you will get the values of derivatives, right? So as per formula which we have done here, see again, this is your formula. Now here x naught plus h is known to be x1. So y at x1, this y at x1 is what? y1. So this point we have taken as y1, whereas this is y0. Now if we calculate the value of y dash at x0, we will get y0 dash. If we calculate the value of y double dash at x0, we will get y0 double dash, and so on. So our formula becomes y1 equals to y0 plus h y0 dash plus h square by 2 factorial y0 double dash, and so on, right? Now all the values you have calculated here. See, you know what is h, you know what are y0 dash, y0 double dash, y0 triple dash, and so on. As much as derivatives you will take, you will get more accurate values. So substitute all the values here, you will get the value of y 1.1. Now this y1.1 become your y1 now. Now what is x1? x1 is x0 plus h. So x1 become 1.1. In the similar way, as you have calculated calculated the derivatives here, you can calculate the derivatives of y1 dash, y1 double dash, all these values by substituting x1 y1 in place of x0 y0 as you have done in the previous step. So calculate all the derivatives. Now you can see, now this is your y1. So y1 plus h become y2. So y2 is y1 plus h y1 dash plus h square by 2 factorial y1 double dash and so on. That means 0 replaced by 1 now, because you have to find the value of y2 with the help of y1. So all the derivatives you have calculated, all the values you have calculated, like triple derivative, fourth derivative, and in the previous step you have calculated other values. Substitute all these values here, you will get the value of y2. So this is your y2. Now also we have calculated the analytic solution as you have done in your previous unit number 1. So analytic solution comes out to be this one. If you just substitute the value y 1.2, that means x key value 1.2, if you substitute here, you will get the result 0.2428. Now just see, this is your accurate exact result and this is your calculated result. So you can find error also by taking the difference between them, right? So this shows that if you use Taylor series method, you can get the accurate values. Not accurate, but ठीक है, 0.2428 and 0.232 is near to 0.2428, and when we solve systems, when we solve physical systems, then approximate values are good enough. Another example. So again I have left this solution part for students for practice purpose. So you can calculate yourself, you can get the values, and you can compare the result with my values, right? So this is your slope now, this is your initial value 0, x naught is 0 and y naught is 1. Now here in this part you have to calculate the value of y1, y2 and y3, right? So these are y1, y2 and y3. So as we have done in previous example, there we have found y1 and y2. So here we have one more step to find y3. So in the similar way as we have done in the previous example, you can find all the values and you can compare these values and tell me whether the values are correct.